CH2 double bond CH2 gas plus H2 gas gives us CH3 gas. Let us now examine the following chemical reaction with the help of concepts of oxidation and reduction which we have just gone through. The reaction is 2HgCl2 aqueous known as mercury chloride plus SnCl2 aqueous known as stannous chloride giving us Hg2Cl2 solid known as mercurous chloride also known as calomel plus SnCl4 aqueous known as stannic chloride. We find that conversion of SnCl2 into SnCl4 leads to the addition of electronegative element chlorine to SnCl2. Hence, SnCl2 is oxidized to SnCl4. Simultaneously, conversion of HgCl2 into Hg2Cl2 leads to the addition of electropositive element mercury to HgCl2. Hence, HgCl2 is reduced to Hg2Cl2. It means oxidation and reduction always occur simultaneously in all oxidation reduction reactions. Hence, a new word, redox, was coined for this class of chemical reactions. Let us now study second part B, which deals with modern concepts for redox reactions. It can be further subdivided into two parts. First, A is redox reactions in terms of electron transfer reactions, or we can say electronic concept. For this, let us examine the following reaction. 2 sodium solid plus chlorine gas giving us 2 Na plus Cl minus solid. This is sodium chloride, an ionic compound. Here we see that 2 sodium atoms are converted into 2 Na plus ions with the loss of 2 electrons, that is 1 electron per atom, as is clear from their electronic configurations. Na atom has the configuration 1s2, 2s2, p6, 3s1, and with the loss of 1 electron, it's converted into Na plus ion, whose configuration is 1s2, 2s2, p6. On the other hand, these 2 electrons are taken up by 2 chlorine atoms to form 2 chloride ions. That is, each chlorine atom gains an electron, which is clear from their electronic configurations given below. Chlorine atom with the configuration 1s2, 2s2, p6, 3s2, p5. With the gain of 1 electron is converted into Cl minus ion, that is chloride ion, with the configuration 1s2, 2s2, p6, 3s2, p6. Now, in the light of classical concept, we will say that sodium is being oxidized because it is gaining an electronegative element, that is chlorine. But in this process, sodium is losing electron also. Hence we conclude that oxidation must accompany loss of electron or electrons, and similarly reduction, for example chlorine changing into chloride ion, must accompany gain of electron or electrons.